Hello everyone, welcome to Detangle. In this video, we'll solve a question related to circuit that has capacitor and resistor. It's a very interesting question. This was asked last year in JEE Advanced 2019. So, let me read the question. In the circuit shown, initially there is no charge on the capacitors and keys S1 and S2 are open. So, the two keys are open. The values of the capacitors are, so values are given. Now, the question is, which of the following statements is correct? So, the first one, the key S1 is kept closed for a long time. So, this key is closed for a long time such that the capacitors are fully charged. Now, key S2 is closed at this point. You are closing this key. The instantaneous current across 30 ohm resistor. So, we need to figure out what is the current flowing through this 30 ohm resistors will be 0.2 ampere. So, they have given the statement that the current through that 30 ohm resistor, current through 30 ohm resistor is 0.2 ampere. You have to verify if it is true or not. So, before starting out, let's run through the basics of a capacitor first. That is, say suppose we have a capacitor and I apply a 10 volt across this. What do you think is going to happen? We know that there won't be any sudden changes of voltage across the capacitor. This is unlike a resistor. You have a resistor and you connect it to 10 volt. We know that suddenly at that instant there will be a current flow such that all the 10 volt will be dropped here. So, sudden changes in voltage will happen in case of resistor, but that doesn't happen in case of a capacitor. Instead of that, what happens is the moment you connect a 10 volt, at that instant there will be a current flow. Okay, there will be a huge current flow such that all the positive charges will be repelled to this point, all the negative charges will be repelled to this point. So, what happens is there is a buildup of positive and negative charges slowly. So, as this buildup happens gradually, the potential initially it will be 0 volt, but it will slowly change to 0 volt, 2 volt, 4 volt, etc., etc. And in that time the current also, what happens is, if some, say suppose for example, say suppose some 2 ampere is flowing starting, the current also will decrease as the potential is increasing at this point, because the potential difference between them will decrease. So, the current also, it will be like 2 ampere to 1.5 ampere, 1 ampere. So, the current also will be decreasing. So, this one will go on, and finally what happens is there will be a full buildup of the charges here on the capacitor such that finally the potential becomes 10 volt. And when the potential becomes 10 volt, we know that if this is 10 and if this is 10, they both will oppose each other, or there won't be any potential difference, hence the current will become 0 ampere finally. So, that is the basic thing what happens in capacitor. So, to summarize that, at instant when you connect the capacitor across a 10 volt, or when you close the switch, what happens is the current flow will be maximum and the potential across the capacitor will be 0, or the capacitor will act as a closed circuit. And after a while, or like you wait until all the charges are getting collected across the capacitor, that is when the capacitor is fully charged, and then when the current flow will become 0. So, after a while, we call this state as steady state. What happens is the current will be 0 and the potential will be whatever the potential you applied, or it behaves as an open circuit, that is it won't let any current to flow. So, that is the basic idea of a capacitor. Also, let's see what will happen if we connect a capacitor and a resistor. That is, say consider this circuit, a capacitor and a resistor, and this is connected across this 10 volt. Okay. So, basically we can extend whatever we learned just now, that is the 10 volt which is applied across this capacitor, initially it will behave as a short circuit, or the current flow will be maximum such that the entire 10 volt will be dropped across this resistor. Okay, but we know that, and when that current flow happens, the capacitor gets charged, that is there will be all the buildup of charges, plus plus minus minus, and when this charging happens, we know that the current value will be decreasing. Why? Because now there will be a potential at this point, and the current won't be finding it easy to move, because the potential difference between these 2 points will be decreased. And then what happens is, eventually once this is fully charged to 10 volt, and that time there won't be any current flow, or this will act as an open circuit, so there won't be any drop across the resistor. So in a way that whatever drop happened at the resistor, the capacitor is going to take away from it, and here the potential will decrease, and here the potential will increase, and it will charge to the maximum potential. Now done with the basics, let's try to break this down. So initially we have a circuit like this, and they are telling that they are closing the switch, and they are leaving this switch closed for a long time. So what happens is, we know that there will be a steady state of capacitors such that all the capacitors will be fully charged, and there won't be any current flow in the circuit. Okay, so let's try to analyze that. That is, here, since this positive is connected to this this plate of the capacitor C4, we know that there will be some charge buildup there. I'm going to take that charge buildup as plus Q at this side, which means that there will be a charge buildup of minus Q on the other side. And because of this minus Q here, we know that all the minus Q buildup means all the electrons would have gone to this side, which means this plate will be plus Q, the same amount, by the same amount, hence this plate will become minus Q. And in the same way, we know that this positive plate induced a plus Q here, and this negative plate will induce a minus Q on this side, and this side will become plus Q. So the idea is, the charge induced should be the same in all the capacitors. Why? Because they are connected in series. So it's just a single connection, so the charges are not going through some different path, it's just the same path. So whatever charges build up happen should be the same. Q amount of charges build up everywhere. Now let's say I'm interested in knowing what are the potential drops happening across the capacitors, because we know that whatever 5 volt you give here is going to get drop across these 3 capacitors. There won't be any drop across the resistors. Let's say I need to know what are the potential drops happening across the capacitors. So I can tell the total voltage 5 volt is getting dropped across this capacitor, that I'll call it as V4, and across this capacitor V1, and across this capacitor V3. So the total voltage is dropped across these 3 capacitors, and if you want, you can just use KVL also, you'll get the same thing, but it's better that if you go according to the logic. And now here I can write this as 5 volt is equal to voltage across capacitor. I can use this equation. For a capacitor, I know that the charge stored should be equal to the capacitance multiplied with the potential across the plates. So here I can write V4 as, we know the charge induced is Q divided by the capacitance of the capacitor is C4 is 80 microfarad, so 80 microfarad. In the same way, for V1 this will be charge induced is same Q by the capacitance is 10 microfarad plus the charge induced is Q and the capacitance is 80 microfarad. Now here I can take Q outside and I can solve for Q, so that I'll get the value of Q as 40 microcoulomb. Now I can easily find out the potential drop happening across the capacitors. That is, for the capacitor 4, V4 is going to be the charge, that is 40 microcoulomb divided by the capacitance, which is 80 microfarad. This is going to be 0.5 volt, and in across the capacitor across the capacitor C3 also it will be the same potential, 40 by 80, the capacitance is same, so this also will be 0.5 volt, and across the capacitor C1 this is going to be 40 microcoulomb divided by the capacitance is 10 microfarad, this is going to be 4 volt. So now we have a good idea that the 5 volt, here the drop is 0.5, here the drop is 0.5, and here the drop is 4 volt. That is, the total 5 volt is getting dropped like this. So what I did is, I just put all the potential values across the capacitor, and they have asked that at the moment when they close this switch S2, what would be the current which flows through this 30 ohm. So to find that, what I'm going to do is I'm just going to redraw this circuit because this still looks messy. So I'm just going to do a very clean circuit here. So here I have this capacitor which has 4 volts, so I can represent it as a cell. It's basically cell, right? There is a positive and a negative potential and connected to 70 ohm. And then we know that here also, if you check the total potential here, that is, this is 5 volt and here it is 0.5 and both are opposing, so the net potential here will be 4.5. I have to subtract, and in the same way here this is negative and this is also negative and the value is 0.5, so again 4.5 minus 0.5, I'll get the total potential here to be 4 volt, the same potential as this. And these two resistors 30 and 100, I've combined them into a single resistor, so it looks good. And again here what they have asked is, this is very important, that they have told that at the instant when you close the switch S2, what is the current flowing? So at the instant when you close the switch, we know that there is going to be a huge current flow in this circuit because the capacitor is going to act as a short circuit. Why? Because initially there won't be any buildup of potential, so the whole current will be flowing through this, so it is basically short circuited. So I'm not considering that capacitor here, C2 here, and then we have 30 ohm resistor and then a 10 volt, and this value of I need to figure out. So to find out the value of I here, I can use KVL, that is current going like this splits into I1 and I2. So if I write a KVL equation in this circuit like this, so I'm just going to write it in a very simple way, that is, here it is 10 volt and 4 volt and they are in opposing potential, so the difference between them is 6 volt. There's a potential difference of 6 volt here, and that 6 volt is going to get dropped as here across this resistor, which will be 30 into I plus, and also across this resistor, which will be 70 into I1. And in the same way for this circuit also I can use KVL, that is, the potential difference across this will be 6 volt, and that 6 volt will be dropped across this as 30 into I plus, also it will be dropped across this resistor, which will be 130 I2. Now we know the relation between I1 and I2, that is, the total current I should be I1 plus I2. So therefore this I2 here, this I2 I can write it as 130 I minus I1. And now if you simplify this further, you will get this as 160 I minus 130 I1. So here I have two linear equations in two variables, and if I simplify this, I should get the value of I as 0.079 ampere. So the first option, whatever they said, is wrong. Why? Because they said current should be 0.2 ampere, but we are getting 0.079 ampere. Now here there is a still better way of doing this, or a faster way in which you can simplify this circuit instead of doing so much of calculation. That is, if you look closely enough, these are 4 volts, and therefore whatever the drop happens between across this resistor and this resistor has to be same. Why? Because the potential across the ends are same, they are in parallel connection, so the drop are same, hence I can combine them into a single resistor. That is, so I'm drawing this one, that is 30 ohm and a 10 volt connected like this, and what I can do is, here this is 4 volt and this 70 and 130 I can combine them, they are connected in parallel, so I can draw a single resistor which has a resistance of 70 parallel to 130 ohm. Now again further you can simplify this circuit, that is, this 10 and 4 volt are connected like positive, so they are opposing each other, which means that the net effect is the 6 volt, and the 6 volt is connected across 30 plus this resistor in series, which means this will be like this, 30 plus 70 parallel to 130. So the current flowing, I can directly calculate it as 6 by 30 plus 70 parallel to 30 ohm, 130 ohm, and if you simplify this also you'll get the same answer, 0.079 amps. So that's how you do it. Now for the second option in the question, if key S1 is closed for a long time, such capacitors are fully charged, the voltage difference between points P and Q will be 10 volt. So the switch S1 is closed for a long time, so we already have a figure here. So it is closed for a long time and they are asking what would be the potential difference between P and Q. So it is clear that the potential difference across P and Q should be 4 volt. Why? Because we know there won't be any current flow once it is fully charged, so it behaves as an open circuit and the potential across these ends will be 4 volt and it is connected to P and Q like this. Or else if you go from this side also, it will be the same. Here it is 5 and 0.5 and 0.5 are dropped here, they are opposing, so total drop will be 4 volt. So the drop should be 4 volt, not 10 volt. So option 2 is also wrong. Now for the third option, at time t is equal to 0, the key S1 is closed, the instantaneous current in the closed circuit will be 25 milliampere. So they are telling that at t is equal to 0, the switch is closed. So I cannot use this figure. So this is basically at a steady state, that is after you close the switch, you wait for a long enough time that the capacitors are charged. So I need an instantaneous circuit. So this is an instantaneous circuit, that is the moment when you close the switch. So that time we know that the capacitors will act as short circuit. Why? Because initially there won't be any potential difference across them, so they will act as a short circuit and the current flow will be maximum. So I am removing all these capacitors here and there will be only resistors left and the current will be flowing through the resistors, and we need to calculate this current, and this current we know it will be the potential difference divided by the total resistance. They are connected in series, so it should be 5 by 200, that is 25 milliampere. So option 3 is correct. Now for option 4, if key S1 is kept closed for a long time such that the capacitor are fully charged, the voltage across the capacitor C1 will be 4 volt. So you are keeping the switch closed for a very long time such that the voltage across the capacitor C1 is 4 volt, which is true because we already found it. So the correct options are 3 and 4. So if you have any doubt, just put down in the comments. We'll have a discussion there, and I'll see you all in the next video. Thanks for watching.